Hello everybody, we've got four BL1840B Makita batteries, or Makita compatible batteries. This one's from Screwfix, obviously genuine, £60. This one is claimed to, no, I lie, flip them around the right way. So this one is claimed to be genuine from eBay. Is it or isn't it? We don't know. This one doesn't claim to be from Makita or genuine or anything else. It's just basically a compatible battery which is sold, and this one came with a impact driver in my shed, which I've been using for a couple of years. There's two of these, a charger which plugs in there on this one, and an impact driver for 49 quid I think it was, or something incredible, from Banggood. It works fine actually, it's good. I mean, it does wheel nuts and all the things I want to do with it. It's a beefy beast of a thing, but cheap. Okay, and it looks cheap, doesn't it, really? So yeah, now if we just turn these over, you can see that actually on the Makita website, the Makita Europe website, it says that if it hasn't got this label, actually it's been stuck on pretty wonkily, isn't it? It hasn't got this label. Just zoom in a little bit, you can have a bit of a closer look on that. Cell made in Singapore, packed and processed in China. CE mark anywhere? Where's the CE mark? Well, no. Well, it's not. It might be for the European market, but it hasn't got the CE mark on it, interesting enough. So work that one out. It's got the recycling mark and the RHS mark, and it's got a thing about not blowing yourself up, keep it out of water, and don't dispose of in fire. No CE mark. Anyway, that's the genuine label that is shown on the Makita website, how to tell whether your battery is genuine. This other genuine one, and if it is genuine we'll find out, won't we? Makita one has got what looks like an American label on it. So it still sells made in Singapore, processed in China. So yeah, I mean, it's an American label, probably a grey import, we don't know. Same part number, same voltage, and they're 4 amp hour. Both of these two are claimed to be 4 amp hour. The replacement one from eBay, which is not claiming to be anything but what it is, which is a replacement, it says quality battery, we'll find out. And it has got the CE mark, but it's made in China, so it's got Chinese cells in there, more than likely, or definitely I should say. But otherwise it's got all the same interconnections and the interface to the electronics in the drill, as well as these two power contacts. This one charges by plugging in there, and it's the same. We'll weigh them all in a minute and we'll see whether they're all going to chooch for us. Before I actually touch any of these batteries haven't been near a charger, they haven't been plugged in, they haven't been run at all. This is exactly how I received them yesterday, well, the last couple of days actually. I only unpacked them today, so these are brand new out of the packet, and I thought it'd be interesting just to see what charge they've got in them at the moment, and since before we touch them. So starting with the equivalent, the £20 equivalent from eBay. I'll get this so you can actually see. So that one's 19.33 volts. This is the original from, claimed to be original Makita from eBay for £44. Yeah, we've got 11.19 volts, so that's pretty discharged, isn't it? It's well below what it should be. So yeah, 11.9, so that one's been sitting around for a while I think, because no one would ship a lithium battery with that little charge in it, because it's really below the sort of safe limit for the old lithium ion. I guess the new ones are more tolerant of being discharged, and this is the Screwfix Makita £60 battery, and we've got 14.75, so pretty low really, pretty low. Interesting. Actually, these have got battery testers on the front, so there's a battery test button there. Let's see what they've got in them when we get them. I haven't tried this actually. So no bar showing on that one at all when received. That's not good, is it? That's absolutely dead flat, that battery. So let's try this one. And we've got one red bar. I don't know whether that means it's flat or whether that means it's whether they turn green or not, I don't know. So that actually, that button feels quite positive, nice button. You feel it clicking. Whereas this other one, which is the one with the US import, claimed to be a genuine one from eBay, that button is just not as nice, you know. You have to push it really hard, and you can't really feel any tactile feedback from it. Tactile feedback from it at all. Yeah, so pretty flat. I've put another one of the cheap Chinese ones, which I got with my tool, on charge, and we'll run a test on that as well, with the safety shut-off enabled rather than a line of code which is probably rogered the other battery. And I'll put them on full charge, give them a full charge, we'll check the open circuit voltages, and then we'll run the test, and then you can see the results. So what I've got is a current clamp meter, impact driver here, and I can just clip onto the electrodes underneath, look, like so. These are quite beefy crock leads actually, it should be man enough for the job for short runs. And then what I can do is the positive is on the left. I've got these copper electrodes which are basically copper heating washers or sealing washers from my toolkit, and the positive is on the left. Wouldn't be a good idea to get this round the wrong way, it'd be disastrous probably, and we can just ease those into the clamps to make electrical contact. Right, and there we go, and the drill has just lit up. My Christmas tree. So there we are, we've got our connections, good copper connections, good solid crock leads, and what we can do now is just clamp this onto here like that. You can see it's zeroed. Let's zero it again just to make sure. Right, anybody guessing what the current's going to be on this thing? 18 volts, don't forget, or thereabouts. Have you made your assumptions about what the current's going to be? So we've got an offset of, let's try and zero it once more. It's settled down now, I've stopped moving it. Because it's DC current we're measuring, any offset or any residual magnetism from the Earth's magnetism or from slightly pre-magnetized ferrite clamps will portray as a current, because it's just a DC offset. So that's zero-y thing. Okay, so we're zeroed and min-max is flashing. Now I can give it the beans now, hopefully it will record the maximum and minimum current for us. So here we go. Okay, and so if we then hit this button, you can see maximum is 5.2 amps. It's a weird way it crept up then. I wasn't fiddling around with the button, I had it fully depressed. I had a full clench on there, boys. So 5.2 amps, maximum current, that's the current used to chooch this thing. But actually under braking, quite interesting, watch this. This time I'm going to let go of it really quickly and see if we get a higher reverse current from the braking function on the actual impact drive. Ready? See what we got. So that time we got 3.59 amps. I'm going to put some more juice in this battery. I did just pick it off the shelf. It obviously needs a bit of a charge, I think. Or the battery's warming up. Make up your minds now. Yeah, so the minimum wasn't much. There doesn't seem to be any braking going on there, so that's fine. So the braking shunt is done inside the unit, because obviously they stop it quickly by shorting the motor basically. The motor starts to try and act as a generator on the overrun, and when you short out the windings or put a low impedance across the motor, it actually acts as a brake and stops it quick. So we've got 3.59 amps and 5 point something amps on the previous run. So let's go down the workshop and just with a freshly charged battery, and let's just torque down a bolt and see what the maximum current is. And then with the test program, an adaptation of the test software I wrote for testing car batteries and chargers, we can do a cycle test to simulate bolts being done up, and then we can fully charge these batteries, have a look at them, run them through the test, and we'll see which one gives the most real world charge and longest duration between charges. So let's go down the workshop and have a look. Right, we're in the workshop. We have a fully charged battery, 15 amp leads going through the current meter to the impact driver with a Barco 3/4 inch socket or thereabouts onto a 22mm bolt on the rear swinging arm of this motorcycle. So I'm just going to activate this on full chat and we'll see what we get. Contact. And you saw we got 17.9 amps maximum current. That was with a bolt that wasn't turning on full power. So there you have it. It goes from 3.5 to 4 amps to 5 amps, and then on full torque, full power, we've got 17.9 or 18 amps, which is 18 by 18, which will tell you, everyone will tell you is 360 watts, something like that. We'll work it out in a minute. Don't rely on my mental maths as my advice. Usually quite good, but doesn't spectacularly let me down, but it was a guesstimate. Yeah, so we've got 17.9 amps maximum with a stalled impact driver. That was more than I was expecting, to be honest, but there it is in, shall I say, LCD black and grey. So there we are. Let's go back to the lab and we'll investigate further. Right, I'm just going to pan around and show you the test setup. So there we've got our battery connected. There, that's our test battery, and that's the first. That's one of my batteries from my workshop that I've been using for about a year, and I'm just testing the software on this actually because I don't want to blow up a good battery. So we've got sense wires here and here, sorry, here and here, which are just going straight to the Yokogawa power meter and giving you that 18.5. You can see the voltage varying, but it's actually the voltage at the terminal of the batteries. As the wiring and everything else is taken out of the loop, it's directly on those copper rings down here, and no resistance, no current. They're just current sense wires, so we're sensing the battery voltage. And then if we go up to the Yokogawa up here, we can see this is the power meter. You can see the current increasing as it goes up through the ramp, and then you can see there is the milliamp hour. So it's integrating. The integrator is started at the beginning of the test. So that's the amp hours, and there's the voltage there, okay. Now if we go across to here, we have the electronic load, and you can see it changing and stepping through the currents. The voltage up there is not so important because here there is a 1 ohm load. Actually it's a 0.5 ohm load. It's getting quite hot, so I put a fan at the top to keep it cool. It's a real Heath Robinson setup this. I'm afraid I was going to melt the front of my power supply. I'm going to check on those in a minute and see how hot they're getting. And yeah, this is being controlled by the software, which is going through the test cycle. Okay, so that's this test gear is connected. All this test gear is connected to the computer actually. But so that's the setup we've got. So this is the test software running, controlling the instrumentation you've just seen. It's the test harness that I wrote for testing battery chargers and power supplies, or design power supplies. So we set it to battery up here. You can just about see this, I think. And then this is the output from the power meter, the Yokogawa. And down here in this section here is the one of key interest. Then down here in this section we've got the battery discharge test, which is the thing that's really, this does charging analysis and also discharge analysis. And this bit here is the bit I've just specifically written for testing these Makita power batteries. You can test any battery on it actually. So it ramps the current up from a starting current at 4.5 amps here. It's four steps up of 3 amps up to 12 amps or 13.9 I think, whatever it works out at, and then a final blast at 17.9 amps at the end of half a second, 750 milliseconds. And so down here we've got the ramp time. So it's the ramp goes up to over 5,000 milliseconds, or actually it says seconds there, but it's actually milliseconds I've done it in, and it ramps up in 4 increments, and at the end there's 700 milliseconds of 17.9 amps, which is what we saw in the workshop. That's what it does. Also, spookily, there's a 4,000 millisecond, 4-second delay, which turns everything off and lets the battery recover like you let go of the trigger and you were just going to do a row of bolts. So this is simulating tightening up a row of bolts. It's quite a harsh test for the battery because every 4 seconds we're starting a new bolt. Okay, so you imagine if it was a boiler or something, or a boilerplate with bolts, you'd be running around with this thing tightening them up. And when we get to 17.9 volts, which is pretty much totally flat, I don't want to screw my batteries completely, but when it gets to 17.9, the test will stop automatically and the load is turned off. And then we will have here number of seconds. You can see it's been going for a while already, for 747 seconds. And you can see the set current changing here as it's ramping up the current into the electronic load. Okay, and here we've got the amp hours. So at the moment, in 761 seconds, we've drawn 1.17 amp hours out of the battery. Remember, it's supposed to be a 4. Some of them claim to be 5 amp batteries, but we'll find out just how good they are and how they compare to each other. And the voltage on the battery at the moment is 18.3, and that 18.3 is the voltage measured when we're running 17.9 amps. All right, so that's that part. So that's cycling through, simulating, tightening up bolts like we did in the workshop, 5 seconds to tighten the bolt up, ramping up, spinning down the thread, getting to the end, tightening it for 700 milliseconds at the end at 17.9 amps, 4-second delay, and we can change all these parameters, and then going back and doing the next bolt. All right. So then if we look at the actual graph itself, yeah, so this is the plot. You can see this is the battery voltage, the blue one. You can see it's dithering coming down. I think it's going to hit 17.9 pretty soon, but bear in mind this is a cheap battery. It's not really getting warm. It's been going for quite some time, and these are the plots. Okay, so there's the average current. No point in plotting the current because it would just be stepping up, and the current load is a constant current load, so it would just show you, steps. And even when the battery gets flat, it will still draw the current that we programmed because it isn't linear. It's drawing the current, so it'll adjust the effective resistance of the load to draw the full current. Okay, so that's the average current. Here's the amp hours ramping up. We'd expect it to go up to about here before it collapses out, but we'll see. And there's the voltage dropping, and when that gets to 17.9 average under load, mind you, it's not the open circuit voltage, and it's difficult to actually find what the load voltage is. The impedance of the cell is pretty low actually. It doesn't change much between 17.9 amps being drawn and nothing. It changes about 100 millivolts, but you can see it's going to stop soon, this one. And I don't know whether this is just this is the cheap Chinese battery that I've had for nearly 2 years. I haven't really let them get flat, and I haven't mistreated them or given them a real hot supper, but it is a Chinese battery, so we won't really know whether this is an overharsh test when this one stops. The battery is not very good. We'll find out. So just having a brief look at what's going on here. There's the that's a hot crock clip on the end. The connection on the crock clip won't matter because the current that's going down, you see other crock clips are completely cold because they're the sensing wires. And is that actually a little bit of heat there? It's like a little bit of heat on the case, but only 30 degrees. Sorry, only 30 degrees. So nothing really cooking there particularly. You can see the current carrying wires are a little bit warm, 25, 30, 28 degrees. This is a standard with all sorts of connections. What have we got on here? A little bit of heat there, 32 degrees. Then running up the current carrying wires, there's the actual resistors themselves, and they're cooking nicely. So they're just over 100, those two resistors. 98 and 108, so obviously there's slightly different resistances there. You wouldn't think so, would you? So I don't think we're in danger of melting anything. I just want to make sure I wasn't going to melt through the front of my Regal. There's actually a plastic clip behind the resistors there which give us what we need in terms of insulation from the front of my kit. So yeah, a little bit of heat being generated, but the current is being consumed. That's the important thing with drawing the current. It doesn't matter where it goes or where the heat goes, as long as the current is coming out of the battery and we're sensing the battery terminal voltage accurately, which I think we are. So there's the Yokogawa. There's two of them actually, but there's one there. We're up to 1.76 amp hours. Look, you can see the current ramping up. Yeah, this battery really took one for the team, I'll tell you that. I commented out this comment down here, which is basically the determination after the last switch off. Yeah, I commented it out because I was testing with the 1 kilowatt DC power supply on the floor, and yeah, I forgot to put it back in again, and this is what's happened to the battery. So that's what happens to a lithium battery if you keep hitting it. It goes, I'm okay, I'm okay, I'm okay. Oh, no, I'm not okay. And it just died. It literally completely died. 1.99 amp hours is all we got out of it. So, right, they're all fully charged. Two cheap chinkies. eBay equivalent, but not claimed to be genuine. eBay genuine. Screwfix genuine. Now both Screwfix ones, look, are giving all the red lights. So the brights are all red. And they're working the same. But look at this, it's quite interesting actually, because that's the battery I killed when I did the original test, which you just saw. It's a couple of days ago for me actually. And if I just measure the voltage on these batteries, I'll put the meter in view so you can see it. We have 20.6, they've all been charged on exactly the same charger. 20.5, but the cheapo eBay copy has got 19.4 on it, and I can't get it to go any higher than that, and the charger says it's completely charged. So yeah, that's a bad sign. I don't know why it would do that, because the battery technology, lithium ion, should be pretty much the same within 5%, I should think. So we've got 19.4 on that one, which is a warning sign, but we'll see how it performs in the discharge test. And here we have on the eBay genuine 20.3 and 20.3 on the Screwfix genuine one. So yeah, strange voltage on this one. The eBay equivalent pack for 20 quid. Wonder why that is. Wonder why that is. Anybody got any idea? Leave it in the comments, but we'll find out when we do the performance check. So let's get onto the software, and I'll run these tests, and I'll just give you a quick kick off, and then I'll just come back with the results. It's the easiest thing. Oh dear, Chinese eBay replacement battery. All I can say is, oh dear. So what we got, you can see the test up here, look. Started off at 18.5 volts or 19 volts, and then went off a cliff down to where the Makita battery said it was on 1 bar and started to dip. And it actually started to dip way before. So yeah, poor 1.78 amps, 136 screws. Not good for the eBay equivalent battery. Okay, here's the grey import genuine Makita battery, and the voltage is quite interesting. It started off at 20.4, and I mapped out the actual voltage. I kept pressing the test button on the battery to see what the transition voltages were between 4, 3, 2 and 1 bar. The test is complete. You can see it started off on load voltage of 19 point something volts, and you see it's quite a sharp knee there, and it went down to 1 bar for some time, so I stopped it at 15.8 volts, so it discharged down to 15.8. okay, I don't think it would go much further because it started to reduce very quickly, and I don't want to damage the battery, so it's spent actually. So that's the full capacity, I'm sure. So we got 259 and 3.43 amp hours out of that one. So that was the grey import Makita. So let's try the actual Screwfix Makita next. Well, there you go. That's the genuine Makita battery from Screwfix, and we managed 283 volts and 3.72 amp hours, so it's by far the best performer. I'll review the charts in a minute. You can see it up here. You can see the voltage came down and started to fall off quite rapidly. Interesting, kind of leveled out where the other one didn't. But that's it. The genuine Toolfix Makita is the best. I'll do a chart in a moment, and then we can have a quick review, and then job done. Well, here's the final result. The chart, you can make your own mind up. I'm not saying a word, but look at it, honestly. So on the left here, on this battery on the left, that's the genuine Makita. That's what it says the genuine label should look like in the EU. And if it's a genuine battery, the latest ones. No CE mark. What's going on there? You tell me. Maybe the Americans don't think they need to do the CE mark because we're not going to be in Europe much longer. And we can make do with the American marks, or can we anyway? So that's the genuine one from Screwfix. This is the one from eBay, which was £42, including shipping. And it's got a grey import US label. That label there is no good for the EU. It's got none of the EU standards on there. It's got American support number. It hasn't got any CE marking. It hasn't got the ROHS bin. That waste bin there isn't on there. Hasn't got the other stickers. Hasn't got the lithium ion warning battery on there and the warning stuff on there. So it's not CE approved. It's a grey import battery. That's why it's cheaper. Someone's got them in from Europe. And if you remember, this one had 3 bars in it, and this one only had 1. No, hold on. This one had 3 bars, and when look back in the video, this one had no bars at all. So it was completely, utterly, totally flat, which suggests that it's old stock. It's been around for a while, because it wasn't even registering any bars on the battery indicator, indicating that it dropped below normal. When I measured it, there's 14.4 volts. Skip back to the beginning of the video if you want to see that. So that's the grey import. That's this one here, and then this one here is the 5,000 milliamp hours. Don't laugh. sold all over the place, all over eBay, all over Banggood, all over AliExpress. Presume it's the same one. There may be multiple copies, but this is, well, look at the figures, make your own mind up, okay? So you saw our bolt tightening simulation where we gave it quite a tough test, and it was with a big impact driver, and we're tightening down a big bolt, and we simulated the current ramp up to the peak of 17.9 amps when it was stalled and tightening the bolt at maximum torque. Okay, so we did those. We did the test. You've seen it earlier, and the genuine one, the genuine Makita from Screwfix, 283 bolts, 3.72 amp hours. The grey import. I've done these twice, by the way, to make sure that there wasn't anything anomalous about the readings. 259 bolts, 3.42 amp hours. One of the cheap China ones out of my workshop that's been kicking around for 2 years, that was dirt cheap. It was £45, including 2 batteries. It managed a mighty 161 bolts at 2.1 amp hours. So, I mean, they've been fine. Now, the new eBay equivalent, this one over here on the right-hand side, had a lower voltage to start with. There was something funny about the voltage on it. Fully charged it up twice, and the average was 136 volts, and it's 1.7 amp hours. So it's not even a 5,000, it's not even 4,000, it's 1.7 amp hours of battery in there. And there's something funny about it because the battery voltages are wrong. And I wonder if it's only got 4 cells instead of 5 or something, and a lump of clay. I might do another video. Have a look after this one. If there's another video, I'll open it up and have a look. And the other cheap China one, which I ran flat and almost killed, still, I mean, it went from 2, do you remember it was 1.99 amp hours when I first tested it. It dropped to 1.68, and it managed 126 bolts. Yeah, you can actually get twice as many bolts tightened out of a genuine Toolfix Makita UK new stock battery, alright? So the other thing about this battery, the copy battery, is that it had a lower starting voltage by nearly a volt, and the finishing voltage was about the same. So, you know, when you put a nice fresh lithium battery in your drill driver or whatever, you get that extra boosted performance. Well, this can't quite deliver the same voltage, i.e. so it can't manage the same power output. So if you've got a real tough job, then it might not be able to give the same performance like a fully charged battery. You know, when you're driving in big screws or doing up big bolts or want to undo some big bolts, it could be an issue, okay, because the motor won't spin as fast. And if you like the video, I hope you found it useful. If you can just subscribe to the subscribe button down in this corner and leave me a like, I'd appreciate that. And good luck if you buy yourself a battery.